So, continuation from what we have covered last time, still applications of differentiation. Today we are going to look at stationary points. Stationary points are divided into mainly two. We have the turning points. These turning points are divided into two. We have the maximum, which maximum is in this form. A curve will form a sort of N. Then a minimum turning point forms a sort of U, like that. Then point of inflection, this one is in two forms. A curve comes from the left, it becomes stationary, then it proceeds like that. Or it can also happen to be coming from the other side, become stationary like that. So this is a point of inflection, like we are going to see in the examples we have. Now, how do we determine the nature of the stationary points? There are so many ways of determining the nature, but in this video we are going to have only two, because with these two methods you can determine the nature of any curve you have, and in a simpler way. The first one, we are going to get the second derivative, that is to say, we differentiate our given curve in the example the first time, then we differentiate the second time, and we substitute in the values of x we get and we see. If it is less than 0, that's automatically going to be a maximum turning point. Then if it is greater than 0, it is going to be a minimum turning point. Then if the second derivative is equal to 0, after substituting in the value of x, for which the curve is stationary, it can either be a maximum, a minimum, or point of inflection. So at this point we need to investigate further using some other method. So this is where we have to investigate further. Then another method is testing the values of x that are on the left and the right of the divide x. And this one requires us to create a table. So we are going to use these methods interchangeably in the examples we have listed here. So our first example in the solution, we shall have part A. Y is equal to x squared into 6 minus x. For us, the question is telling us to determine the stationary point and distinguish between the stationary point. Is it a minimum? Is it a maximum? Is it a point of inflection? That is what we are going to do. But we have said that the first method is you differentiate, then after differentiating, you substitute in the values and see. So since we need to differentiate, we can differentiate this as a product, but not to waste time, we can make open brackets, and we have it as y is equal to 6x squared minus x cubed. Then we get the divide x derivative, which is the y, the x is equal to 12x squared minus 3x squared. Then having established this, we should note something, that at turning points or at stationary points, always our gradient function is equal to 0. Change in y over change in x is equal to 0. What does this mean? It means that if I have my curve like that, let me use an example of a maximum like this. This is having a maximum turning point. So if this is the maximum turning point, I'm looking at a point where this curve is turning. This is the value there. That is the y value. And that y value is constant. Sorry, this is 12x. Yeah. Our y value is constant here, so we have it as y. Then our x value at this point can be x1, then this is x2. How do we get gradient? We say that gradient, which is m, is change in y over change in x. In this case, our change in y, it is the same value for y. So in case this was y is equal to 3, it will be 3 minus 3 over, in case the x value was say 2 and it goes up to 4, this will be 4 minus 2. So numerator automatically has a 0, irrespective of what you get in the denominator, that is a 0. So it means that if you differentiate this, you get a 12x minus 3x squared. Then we know that at this turning point, at this stationary point, our y x is 0 is equal to 0. So we get this and equates to 0. So we shall have 12x minus 3x squared is equal to 0. Then simplifying this one, we are going to factorize out. A common term is a 3x. We remain with 4 minus this is going to become, this is going to take out 3, it's going to become x, this is equal to 0. Because when you open brackets, we come up with 12x, then minus 3x squared. Then I want to establish the value of x at that specific turning point. So I will come here and say either, I'll say either 3x is equal to 0, this one here equated to 0, such that x is equal to 0, this is the first value of x, or 4 minus x is equal to 0, meaning that x is equal to 4. Now we go to the second derivative because we want to get the nature. So we come to we have 2 points. We have the one of x is equal to 0 and also x is equal to 4. What we are going to do is we are going to get the exact value. You get the coordinates of x and y, so you need to get the y coordinate. If I put in if x is 0, this is going to become 0 times 0. So this becomes 0, 0. Then when I put in 4, this is 6 minus 4, that's 2. Then 2 times 16, that one gives us 32. So we have something like that. So our aim is to see, these are the turning points, true. But what are they? Is this a maximum, minimum point of inflection? Is this a maximum, minimum point of inflection? So we go ahead and get the second derivative of this function here. So getting the second derivative, we differentiate the second time. And when I differentiate this the second time, I'm going to come up with 12 minus 6 minus 6x. Then I'm going to substitute in the value of x. I put in the value of x and I see what am I going to come up with. So I'm going to start by saying the squared y of x is squared. This is when x is equal to 0. When I substitute, it's going to be 12 minus 6 times 0. So this one gives me a 12, and the 12 is greater than 0. It's a positive. So automatically this one shows that at point 0, this is automatically going to be a minimum. Since this is greater than 0, it is a minimum turning point. Then I also substitute in the second derivative the squared y of x is squared. This is when x is equal to, my x value is 4. I substitute in, it's going to become 12 minus 6 times 4. This is going to be 12 minus 24, which is a negative 12. So this one, since this is less, when you look at this one, you say if it is less than 0, and all values that are less than 0 are negatives on a number line. 0, all these values are negatives, all these ones are positives. So positive gives us a minimum, negative gives us a maximum. So automatically this is going to be maximum turning point, this one here. So in conclusion, I'll therefore say that the curve is having turning points 0, 0, which is a minimum, and 432, which is a maximum. So that is what we have for this